welcome back to the AI Academy. This is our third lecture on your learning journey in natural language processing. In this video, we're going to dive into the challenges in NLP and designing NLP systems to handle them. So, we know that the natural language processing or NLP is a complex field at the intersection of computer science, artificial intelligence, and linguistics. Its goal is to enable computers to understand, interpret, and generate human language in a way that is both meaningful and useful. Despite significant advancements, several challenges continue to delay the development of fully functional NLP systems. Today we will discuss about some of these challenges, providing a comprehensive overview of the difficulties faced by researchers and developers in this dynamic field. Let us first discuss about the ambiguity in language. So, one of the primary challenges in NLP is the inherent ambiguity of natural language. Ambiguity arises at multiple levels like lexical ambiguity, where same words can have multiple meanings. For instance, the word bank can refer to a financial institution or the side of a river. Next is syntactic ambiguity, where sentences can often be parsed in multiple ways. For example, the man saw the woman with the telescope can mean either the man used the telescope to see the woman or the man saw a woman who had a telescope. And the last one is semantic ambiguity, in which the meaning of a sentence can be unclear. He saw her duck can mean he saw a bird called a duck belonging to her, or he saw her lower her head quickly. These ambiguities make it difficult for NLP systems to accurately understand and process natural language. The next challenge is context and pragmatics, so, understanding the context in which a word or sentence is used is crucial for accurate interpretation. Context includes situational, cultural, and conversational aspects. For instance, the word jaguar could mean a car, an animal, or a sports team depending on the context. Pragmatics, which deals with language use in social contexts, adds another layer of complexity. Irony, sarcasm, and indirect requests often require a deep understanding of the context and cannot be easily interpreted by computers. Another challenge is the variability in language. The natural language is highly variable. There are numerous dialects, sociolects, and idiolects. People use different words, structures, and tones based on their background, which includes factors like geography, education, and social status. Moreover, language evolves over time with the introduction of new slang, expressions, and even entire languages. This variability makes it challenging to create NLP systems that can understand and process language accurately across different contexts and populations. One more challenge is lack of common sense knowledge, as we know humans use a vast amount of implicit knowledge to understand and generate language. This common sense knowledge includes understanding that if someone is holding an umbrella, it is likely raining or they are protecting themselves from the sun. Computers lack this inherent knowledge, making it difficult for them to comprehend text in the way humans do. The next challenge is data quality and quantity, so, the NLP models rely heavily on large datasets for training. However, acquiring high-quality, annotated datasets is expensive and time-consuming. Furthermore, these datasets often contain biases that can lead to skewed or unfair results. For example, language models trained on internet text might inherit and even amplify the biases present in those texts. The multilingual and cross-lingual challenge is that, for developing NLP systems that work across multiple languages or can translate effectively between languages, is another significant challenge. Each language has its unique structure, vocabulary, and idiomatic expressions. Cross-lingual NLP involves not only translation but also understanding and generating content in a way that preserves the meaning and cultural nuances of the original language. Computational efficiency is another challenge in processing natural language. Requires significant computational resources. Tasks like parsing, machine translation, and language generation involve complex algorithms that can be computationally intensive. Ensuring that NLP systems can operate efficiently and effectively on standard hardware, and in real-time applications, remains a significant challenge. Addressing these challenges in NLP requires innovative solutions and approaches that can enhance the robustness and accuracy of NLP systems. We will discuss about various strategies and techniques used to design effective NLP systems. So, to handle ambiguity challenge you need to manage the lexical, syntactic, and semantic ambiguities. Multiple strategies are employed, like for lexical ambiguity the word sense disambiguation, WSD, algorithms are used to determine the correct meaning of a word based on its context. Techniques such as supervised learning with annotated corpora and unsupervised learning using clustering methods are common. For handling syntactic ambiguity, the parsing algorithms like probabilistic context-free grammars, PCFGs, and dependency parsers can help identify the most likely syntactic structure of a sentence by considering probabilities of various parse trees. And for the semantic ambiguity, the semantic role labeling, SRL, algorithm assigns roles to words in a sentence, helping clarify who did what to whom. This, combined with context-aware models, can reduce semantic ambiguities. Let us now talk about incorporating context and pragmatics, so the contextual understanding is improved by contextual embeddings. The models like BERT, bidirectional encoder representations from transformers, and GPT, generative pre-trained transformer, use transformers to generate embeddings that capture the context of words within sentences. These models consider both the left and right context of a word, providing a more nuanced understanding. And for pragmatic understanding, dialogue systems and conversational agents use context tracking mechanisms to maintain and utilize the conversation history, helping to interpret utterances based on previous exchanges. To manage language variability, training on diverse and representative datasets helps models learn different dialects, sociolects, and styles. Techniques like data augmentation, where existing data is modified to create new training examples, also enhance variability handling. And pre-trained models on large corpora followed by fine-tuning on specific tasks or domains can adapt to different linguistic nuances more effectively. The next step should be of integrating common sense knowledge graph, structured like ConceptNet and WordNet provide relational data that helps models understand relationships between concepts. Integrating these graphs with NLP models can enhance understanding. And also, the pre-trained models on vast datasets that include encyclopedic knowledge, like GPT-3, can infer common sense knowledge to some extent. You should also be ensuring the data quality and mitigating biasness using data annotation processes involving multiple annotators and consensus methods can improve dataset reliability. And using bias mitigation techniques such as adversarial training, bias detection algorithms, and diverse sampling during training can help reduce model bias. You also need to find a way to address multilingual and cross-lingual challenges, so an effective solution may include multilingual models like MBERT, Multilingual BERT, and XLMR, Cross-Lingual Language Model, RoBERTA are designed to understand and process multiple languages by training on multilingual corpora. And also use neural machine translation, NMT, models for translation, such as those based on transformers, use attention mechanisms to provide accurate translations. Cross-lingual transfer learning allows models to leverage knowledge from high-resource languages to improve performance in low-resource languages. Next, consider about enhancing computational efficiency, using model optimization techniques such as model pruning, quantization, and knowledge distillation reduce model size and increase inference speed without significantly sacrificing accuracy. Along with using architectures like transformers with efficient attention mechanisms, like longformer, can handle longer sequences more effectively. Parallel processing and distributed computing further enhance efficiency. By addressing these challenges with innovative techniques and robust methodologies, NLP systems can be designed to more accurately understand and generate human language, bringing us closer to the goal of seamless human-computer interaction. We hope this lecture has provided you with a clear understanding of why NLP is important and the key challenges and the possible solutions. These challenges push us to innovate and develop more sophisticated and effective NLP systems. Stay tuned, and we see you again in the next video. Thank you for watching. Please take a moment to like and subscribe to keep us motivated.